December 14, very early in the morning, with Jim Scott.
1:57 it says.
And why don't we talk a little bit, Jim, just in general, what the Moog plant was like when you got there in 1969?
It was located in Trumansburg, New York, which is a small town turning into a bedroom community, but had its own character. Still surrounded by dairy farms and cornfields and such for miles around. Um, and the Moog Company itself is located in the former Baldwin's Furniture Store in Main Street, in a town with the main street's 2 blocks long. Um, the so basically it was a storefront with the display windows in the front, which had some uh, displays actually for the, I suppose, the benefit of the local populace, so they could try to figure out what was going on in there. Um, we occupied 2 floors of a 2-story building. Downstairs was production, where the uh, people assembled the circuit boards and the modules and so forth, with a shop in the back for bending metal and doing the photo etching of the panels and sawing up the lumber to make the cases, at least on prototypes, if not in some production also. And an electronic music studio was also maintained downstairs in a soundproof room. It was soundproofed around the sides. It was, but not soundproofed on the ceiling. And directly above was the engineering department, so we had a clear hearing of what was going on down there from down below. Upstairs were the offices, Moog's office and the sales manager's office and receptionist, and the engineering department, which consisted of somewhere on the order of 4 to 6 engineers, depending on what time we're talking about. And also a large storage room upstairs known as the dungeon, which stored a lot of prototypes and junk and old parts and instruments now of historic interest, if they had survived, and some did and some didn't. The conference room was out the back door and on the roof with a view of the creek. It's about the only private place in the building if you wanted to have some conversation you didn't want other people overhearing, personnel or such type things, or just a private place to talk.
Let's talk a little bit about the relationship between Mr. Hughes and Baldwin, about the creative and the financial aspect of it.
Oh, back to politically sensitive issues. I guess I should start by saying that Bob's heart was really in the right place. He really wanted to and did make a contribution to the field of art and or music and so forth in general. Sometimes, or perhaps typically, that involved getting the projects that were not exactly designed or didn't have the effect of furthering the existence of the company. In a sense, that there were a lot of projects that took up a lot of our effort that could have been spent on developing products that might have become staples of the business. Moog hired a business manager by the name of John Husar, who was a very abrasive person, very blunt, and he and Robert Moog were often very much at odds as to policy, as to whether to do something that made a lot of sense. And sometimes Husar was right, sometimes Moog was right. You can't say that either one of them was, because Husar didn't have much of a sensibility or a sense of the artistic end of the thing. He just wanted to run a company that made money and could survive. I recently met Husar in the last few years and heard his side of the story, which I'd never heard before. And it's in great contrast to the account of the same events as you might hear from Robert Moog. Where does the truth lie? One must listen to the evidence and decide, I suppose. We had um, a lot of engineers and very few people like technicians and draftsmen. We basically, as engineers, did all our own technician work, building, and did one draftsman we did do things that we weren't willing or able to do, such as lay out control panels of the actual artwork to make. Somebody has to make up these dials and make up the legends on control panels. And, when we did the way we worked was rather informal. There wasn't a lot of meetings and high level wasting time discussing strategy. Somebody had an idea, you basically went with it. Very often a module got designed because somebody had an idea, and they just sort of went off on their own and did it. The time to market was often measured in days. We had it documented well enough within a few days you could build more of them and take orders for things. The MInimoog was really a team project, because I said we went from concept of a model, I believe it was, to being able to deliver units by, as I remember, we delivered the first unit by probably Christmas of 70, if I'm getting the dates right. And I recall it was delivered to a kid in Ithaca who wanted to buy it, or something like that. Somebody got an awful piece of junk, considering how preliminary it was. A prototype after all, and we still had a number of problems to work out in the first few units.
Was that the first D model?
Yeah, I believe so. I believe the first D model was sold to somebody locally. That's a kind of a fuzzy recollection on my part, so that is really subject to doubt. Better ask other people, see what they might remember. Remind me what I was going to lead into, how we did things.
Oh, the cakes.
Oh yeah, that's a good example of how we people working at the company often had other skills. For example, our purchasing agent had been a tool and die man. He was really good for doing things like the design of the wheel itself, the pitch bending wheel. He just went down to the shop, turned on the Bridgeport mill, and got busy grinding on metal and plastic, that sort of thing. We had built up the electronics box with the control panel, and we had a keyboard. But we didn't have a case. We hadn't really figured out. We'd bent up metal, built up this box, and now what we going to do with it? The draftsman I mentioned at one, Jim Amy, was a good shop. He had his own wood shop. He made furniture and stuff. That was, he had a lot of talents like that. So he went down to the wood shop, hauled out some walnut, sawed it up, made sketches as he went, and built the case. Then he went back upstairs and made the drawings. The drawings were right from the beginning. There was no messing around. And we worked a lot of crazy hours, we worked a lot of long hours, and we were having a lot of fun because we were in a very innovative phase of electronic music. Basically, anything you did was a winner because it was the first one there. So if you came up with an idea and did, in retrospect, you might have done a lot better, and in the future, you probably would improve on it a lot. And Hemsath one of the engineers used to have a joke that when things didn't turn out the way you expected, he said, advertise it as a feature. And for example, here's an example. At one time, we had made an effort on our voltage controlled filters, which have a resonance or peaking in the frequency response that gives it a tone color, a resonant sound. And we were carefully designing them so that if you peaked it up too much, it would go into oscillation. And so we went to a lot of trouble to make sure that it would not go into oscillation because that was supposed to be bad until we discovered that you could use the filter as a sort of an oscillator to good effect if it did go into oscillation. So then after that, we, instead of messing around, fooling around, trying to figure out how to keep it from going into oscillation all the time, we just advertised it as a feature. But it was legitimate. I mean,
Earlier, you and I discussed at some length, in some technical detail, why the MInimoog was successful. We know it had a unique sound, and the musicians
the
understood
mystique
it.
of the Moog sound.
But there was more than that. There was actually some technical reasons about the oscillators not locking and some things. Could you address that? Some of those ideas?
Well, Moog certainly, um, uh, the success of an instrument like the MInimoog was based largely on the sound quality, and there were a number of aspects to that. And one of them was the oscillators, of which there were 3-tone oscillators, which could be usually tuned in unison or a chord or octaves or something of that sort. Probably most typically in unison, I would presume. The idea of 3 oscillators running in unison is the same concept as having 3 piano strings under each hammer in the piano. They're all vibrating independently, and they're never quite perfectly in tune. You know, one will always have a pitch slightly higher, a few cents higher or lower than the other one, or something like that, and it gives a lot of depth to sound because as the wavefront, the acoustic wavefront, is constantly moving and rolling a little bit, as the wave crests come into alignment and reinforce it and fall out of alignment and destruct, it turns out to be musically pleasing to the ear to hear something like that, as opposed to a single oscillator that's going boo and boring the hell out of everybody. Because one of the big problems we were aware of and tried to address all along in designing instruments of that day was the realization of how do you liven up the sound? What do you do to make the sound interesting to the ear? And listening to a sine wave oscillator is probably the most boring thing in the world for a few seconds. And we were always fighting that one. So the depth of the sound, of course, was due to running 3 oscillators, let's say it's the same pitch, and having them slightly out of tune, because it's not possible to get them perfectly in tune and have them stay there anyway. And you didn't want them to, besides. One of the well, let me back up a little more. We were guided often not so much by specifications or by looking at waveforms on oscilloscopes, but by our ears. We're what you might call musical engineers. We had at least an ear for music, if not a talent for it. And so we're always guided in our design decisions by what did it sound like, first and foremost. And so some of these things that happen may have happened by accident, but had they not had accidentally happened that way, we would have worked to make them happen that way anyway. And one of these was the fact that the Moog oscillators were truly independent. That is, if they were very closely tuned to one another, which they often were, but just by accident, or as they drifted a little bit, as the room temperature changed a little bit, they maybe fall almost exactly into tune for a while, then they'd be out of tune slightly as the room warmed up a little more, or phase of the moon changed, or whatever happened. The oscillators would never lock to one another. That is, they never get to the point where the pitches are changing and all of a sudden they grab together and hold together and then jerk apart. And that gives a real jerky, if that happens in oscillators, that gives a very jerky aspect to the sound. It's very displeasing to the ear. It's an ugly sound. The Moog oscillators in the studio equipment never locked, and the Moog oscillators in the MInimoog never locked. They were truly independent of one another. We didn't design with the intent of doing it that way. It just turned out that way. Again, we would have, if they had locked, we would have been looking into it, try to find out what was going on and try to find a solution. But later on, as I said before, we built this thing and we designed it in great haste. And some of the circuitry we went back in the future and either redid the circuit boards so they're easier to build, or made some minor improvements in the design, or more major improvements in the case of the oscillators, which later on were much more stable than the early ones. But at one point, they decided that the power supply that we originally had done was a little too noisy. And probably couldn't hear it in the output, but it was a noisy power supply, so why not go back and put a clean one in? So I believe Bill Hemsath did this. I think he experimented with a clean oscillator in his first, or clean power supply that didn't have a lot of coming in on it. And he made a discovery that that the oscillators now would lock. The fact that there was some dither in the system, some disturbance, some jerking around all the time on the power supply couldn't be heard. It was filtered out along the way in the circuitry, but it definitely was noticed by the oscillators, which that disturbance was enough to jerk them around a little bit all the time, so they wouldn't never go into lock with one another. So the idea of improving the power supply went out the window in a hurry. You were asking about the Moog sound. Oh, of course, there was the Moog filter, which is a patented filter. And there was also, we were concerned in those days, the circuits were often tended to be a bit noisy as far as hiss type of noise, random noise. And so to overcome that problem, we drove all the stages, that is the voltage controlled filter and there were several stages of voltage controlled amplification and just plain old straight out amplification from in the sound chain. And we drove all those stages into mild distortion. So we had probably 4 stages of mild distortion
to improve the signal to noise ratio.
Yeah, we're driving the stages hard, so the signal is large compared to the noise generated in the stage. And that was the main reason for us doing it that way. It was just, again, we're guided by our ears. We need to get the signal up a little higher. Where we're going to tweak the signal up so we can get this output a little louder. But the result was that you had 4 stages of soft distortion. So you add a little distortion here, then you had distortion, add a distortion, which is the multiplying effect. You get two frequencies here mixed together through the distortion. You get 4 frequencies. They go on again. You get 16. You get 32 or whatever it is. And it fattens up the sound. The Moog was known as having a quote fat sound, and that was a lot of it was just due to that. And the Moog Census, the MInimoog was designed initially with no integrated circuits in it whatsoever. It was all done with transistorized circuits, transistor discrete circuits, transistor resistors, capacitors. And the distortion characteristics of those amplifiers is different than if you use an op-amp type of circuit, where the op-amp is driven to the point where it suddenly begins to clip, and you get very hard distortion, which starts with the onset on it is instantaneous, rather than soft distortion, which gradually gets more and more distorted as the level gets higher and higher and heavier, but never gets into the level where you clip the signal and create a harsh effect. So that had a strong effect on the Moog sound. I was asked to talk a little bit about the arrangement or the Moog filter and an ARP incorporated infringement on the filter patent. Let's see, where do we start here? When we designed the MInimoog oscillators, Moog came up with an idea for the improvement of the oscillators so they're more stable than what you had in the modules over here. And he proposed it initially. We initially started out the MInimoog with an idea of a cheap and dirty machine. It was a lot less of a musical instrument than what we ended up with. We were going to try to make a $600 instrument or something like that and sell like hotcakes. I looked at the circuit that Moog had proposed and realized that with some simple feedback in the circuit to control one of the 2 transistors used in this exponential generator we talked about before for converting linear voltages to exponential pitch, I realized that if we put a feedback control loop around one half of this pair of transistors, then in fact it would be an extremely accurate envelope generator. Still temperature sensitive. That was another problem that had to be solved, but at least the
exponential.
What I say? Oh, I said exponential. You're right.
Right.
Correct me when I do this. 'Cause
No, that's okay. Just say it again. If you did it around this curve again.
yeah, if you put a feedback control around one of the two transistors in the pair to stabilize the current to make it absolutely constant in one transistor, then the other transistor became an absolutely perfect exponential generator. Not temperature stable, but or at least you stabilized one. You stabilized the range, but not the scaling, as I recall. And so we designed that in to the MInimoog. ARP Synthesizer Corporation by that time had I guess had their first instrument out. Approached Moog and informed Moog that we had accidentally infringed on a patent that they had been issued on this type of circuit, and they
Is this the so-called analog circuit?
yeah, exponential and analog are the same two words that mean the same thing. And offered to let us use that patent in exchange for their being able to use the Moog filter circuit, which Moog had. The only thing Moog ever patented was the filter circuit, at least back in the Trumansburg days, with some more issued in when the company moved to Buffalo area. And Moog's patent attorneys looked at it and realized that ARP had left a loophole in their design, depending on which transistor you call the reference and which one you call the analog circuit and how you control the loop. Well, we had accidentally, just by pure happenstance, I had chosen when I did the circuit, I had chosen the loophole in ARP's design or in ARP's patent. They just forgot to make a claim, is what they forgot to do, and they hadn't claimed this. The only reason I did it was just for pure convenience about the control voltages being inverted, not inverted, and not inverted. It was more convenient, took less parts if I did it the way I did it. There's no technical reason why I should do it one way or the other. So we told the ARP folks that basically, no, you don't. We're not infringing on your patent. You can't have our filter. And the next instrument that ARP came out with, I forgot what it was. Was it the Odyssey or the Odyssey?
2600 was the one.
The 2600. It had a sound that sounded suspiciously like they were using a Moog filter in it, and the filter was encapsulated in a big block of epoxy, black box of plastic. That we had, I believe, at the time, Rich Wahlberg was one of our engineers later on. He was a very good engineer, and his design involved a lot of design in the after we moved up to the Buffalo area. But at this time, he was working for the company, I think, as a summer student. He was still in college, and he was given a methylene chloride and a Bunsen burner, and he boiled in an ice pick, and he boiled and chipped away at one of ARP's filters for a while to get the epoxy off, which was a real hard job because the transistors themselves are encapsulated in epoxy too, and you end up with just 3 leads in the air with what used to be the transistor there, and so forth. But he verified that in fact they were infringing on the Moog patent and hiding it in a block of plastic. This began. It was a long session of sparring between lawyers. What Moog was seeking to do, and this continued on, I think, for several years, as I recall. The only thing, the ARP company survived a lot on their marketing and sales effort, and less on good engineering. Often, they spent a lot more on that area, and they beat Moog actually in the market for a period of years, taking that approach. The only thing we wanted was a slap in the face. We wanted to force them to put a label on the back of their instrument that said manufactured under license, patent so and so Moog music, to stick on the back of their instruments and to deflate their hype. And as you might expect, what happened was that not much happened. there's a lot of legal sparring and recriminations back and forth, and some personal animosity between principals and the companies and everything else. Um, uh, and I think by the time you know we had got to the position of winning the case in court or out, the instruments in question were out of production, and it all kind of collapsed into a whimper. You may know more about that, Tom. Were you involved in that in later phases?
Yeah, I knew something about it.
Yeah.
In actual fact, ARP paid a nominal fee, as I recall, $20,000, and they quit. They quit putting it into the 2600. So it's interesting that some 2600s have it, some don't. That's my understanding. I haven't actually verified that in great detail.
I should probably point out that I don't know some of these things because my career with the company was on and off. I worked for a couple of years, was out for a couple of years, back in for a few more years, out again, back again. So some of these phases I wasn't around when things happened.
Speaking of design, we've worked together. I mean, in my help in functional design, and yours, of course, in the technical design of things, and musical.
Yeah, we've managed to confuse each other quite a bit over the years.
But you've often referred to the concept of designing from the outside in. So,
that was my personal approach to designing musical instruments was to, for example, I don't know if this is on. This is the Micromoog, which is the one instrument that I really was the instigator of, and the person who did most of the design and so forth. I shouldn't take too much credit for it in the sense that all the circuitry is basically a simplification of the MInimoog, which was somebody else's concept, when the MInimoog itself was a simplification of the studio equipment. So,
however, your oscillator did not drift.
well, by that time we knew how to do an oscillator that really was rock stable.
On the other hand, some instruments that came after the Micromoog didn't take it. It didn't avail themselves of that stability.
I guess the first really stable one was a Sonic 5. Actually had a stable oscillator in it, and it had it because it was using an integrated circuit that the actual chip inside had a little oven. It was its own little oven, and it kept itself at a constant temperature, so you didn't get the temperature drift. That same concept in a lower cost design was used here, where I used an array of 5 transistors in one. So it looks like an integrated circuit, but it has 5 transistors inside. And 2 of the transistors were used as this analog circuit to do the musical translation from linear to exponential musical scale. One of them was a constant current source, which you need for keeping the whole works the current constant in one of the transistors. And then I used one of the transistors, 4th transistor, as a thermometer, because they make since they're temperature sensitive, they make good thermometers if you do it right. And the 5th one as a heater. And then we designed a circuit so that the amplifiers around the feedback loop around this whole arrangement of transistors kept it exactly at 55 degrees centigrade all the time. It took a few seconds to heat up, and it was there forever. So that was the end of the line as far as that sort of analog oscillator circuit that didn't depend on digital tuning. But it was so accurate that a number of people accused us of using digital tuning in it, when in fact it did not have digital tuning in it.
What about the concept of outsiding?
Oh yes, we're back to that. My personal approach to designing things is to and that's what I did here, was to design the control panel first. Lay out the panel, define all the functions, define the interrelationship of all the controls and how they all worked first, with a good idea of how you're going to do it. You know to a point of a block diagram, and also some circuit detail of how you're going to do it. But don't do the circuit design first. Get the panel laid out with all these controls here all figured out how they're going to connect one to the other inside, and then go back and design circuitry. That was my personal approach. Uh,
Why is that a benefit?
um, well, in contrast, um, Robert Moog and David Luce both tended to work the other way around, from the inside out. And the problem that led to in instruments like the Polymoog synthesizer is a good example, was that the control panel that the person who had to play this thing was presented with was kind of an afterthought. Oh, how are we going to do this? How are we going to do that? Beautiful sound generating circuitry inside, but the interrelationship of how circuitry inside connected one to the other, and the more importantly, how one designs a panel to make it apparent to the user how to use this thing, um, uh, was lacking. I think. I used to say that I used to say that the advantage I had over Dr. Moog and Dr. Luce was sometimes I was a lot dumber than they were, and had probably a better appreciation of what uh, people of more average intelligence, let's say your average musician, um, could understand and couldn't understand. So that's always been my belief, just in general, for things other than musical instruments, that sort of approach is uh, is the proper way to go about designing things. I have a personal animosity toward bad design all in everything I come around, and I'm always going around saying that's bad design, because simple example is a Coleman lantern. Or one of these lanterns you carry around has two little fluorescent tubes in it, and it has a three-position switch. The off position is in the middle. One tube is that way, two tubes is this way. Trying to find the middle to turn the damn thing off where you're one-handed when the thing's hanging from a string in a campground is practically impossible. You have to put down whatever you have, grab the thing, and hold it, and then work to find the middle position to turn the damn thing off. That's an example of bad design.
Why did Moog music fail?
In the end,
Yeah.
I can't give you the whole answer to that question because I wasn't around for the end, and I was worked on and off for the company over a period of 10 years or something like that. In the early days, as I mentioned before, a lot of our effort was put into specials, which were not, of which not much money came immediately, and often there was no benefit afterwards. So, although, as I pointed out before, also that's where a lot of some innovative ideas came from, or important innovative ideas came from. The company was relocated when Bill Waitena and his venture technology, we refer to it as vulture technology, took control of the company. The agreement had been, as I mentioned previously, that research and development would be done, and modular systems, the studio equipment would be done in Trumansburg, the mass production would be done in Buffalo. The MInimoog was supposed to be phased out, and the Sonic 5/Sonic 6 was supposed to be the mass-produced instrument that was going to be the economic base of the instrument of the company. And once Robert no longer had control of the company, Waitena pulled the chain and moved the whole operation to Buffalo. At that time, there was a mass exodus of people, myself, him, Sass, Chad Hunt. The only person from Trumansburg besides Moog who went up there to Buffalo and stayed, I think, was the service manager. Can't remember his name. He went with one of the tape recorder companies later on. Lives in Nashville.
Not Bob from the days of Cheektowaga.
No, I've forgotten his name. It'll probably come back. Then there was
Why was there an exodus?
Nobody wanted to live in Buffalo, for starters. That was probably the most important reason. I know I was planning to go up there, and I was at the time married to my first wife. We went up to Buffalo, looked around. She said, "You may be moving to Buffalo." but I am not.
So well,
Which was a crisis in our marriage, but I didn't go to Buffalo.
but later you did.
Yes, later Tom Ray and David Luce recruited me a couple of years later. Um, I've been working for National Cash Register in Ithaca. In fact, several of us went to work there at the same time. They were hiring. One of us got a job and said, "Hey, what a job, National wants people." So myself and Bill Hemsath and Jim Amy ended up at National Cash. I had my taste of what it's like to be in a big company, which is night and day different from what a small company full of crazy, innovative people was like. Good crazy, not bad crazy. Um, so, uh, so the offer was made for me to come back and work for the Moog company in Buffalo. So I worked on an arrangement with the Moog company and with my family that I would travel up to Buffalo on Monday, travel back on Friday, and work up. I'll be in Buffalo 4 nights a week, and home 3 nights a week. And I did that for several years, and that's when the Micromoog was developed. Was in that period. Um,
But you also developed a polyphonic instrument.
that was later. That was in my third uh,
Incarnation.
third session with the Moog company. You want me to talk about that? I don't know.
Well, if you have other things to say about that,
You were on a subject of how we failed.
yeah.
We want to
Okay.
go on to the Micromoog and the Polymoog
Well, it might relate, but
later on.
whatever your thoughts are on failure would be useful.
We moved to an abandoned gelatin factory, Chalmers Gelatin Work, I think it was, in Williamsville, New York, suburb of Buffalo, and we're there for several years. I forgot how many, and um, and that's where the Micromoog was developed. When we were done with the Micromoog project, when I had finished pretty much, we had this in production. The question is, okay, what project is next? What should I do next? My suggestion had been that we have to go and start making programmable synthesizers. That we need to have an instrument. This is 1974, because it was the 74 NAM where we introduced it, was it not? Yeah. And so I said, we need a programmable instrument, an instrument that you don't have to fiddle with all the knobs to figure out how to set it and to get from one sound to another in a hurry in performance. And I'd figured out that I could actually make this instrument fully programmable for all the functions here with 1 kilobit, not kilobyte, 1 kilobit of memory, which is a pretty good sized memory chip in 1974. It was just becoming available, I think. CMOS battery backed up RAM, and it wouldn't be too big a job. First of all, we had the instrument totally defined, so we didn't have to dork around with trying to define what it is we're going to do. We're just going to take this instrument and make a programmable version of it. Leave all the knobs, maybe make it a little bigger to get the programming controls on it. And I was vetoed. And around this time, Oberheim came out with a machine that was programmable, at least partially programmable. I forgot what it's called. And I forget whether it came out before or after I made the suggestion. It may have come out before, for all I recall, or maybe even after. I think that was the beginning of the end, was the failure to get into a programmable instrument right away, as quickly as possible. First of all, to get the recognition of having a programmable instrument, to keep the cash flow going, to get the expertise ourselves as to how we want to go about doing this sort of stuff.
And to meet what the market was asking for. Why were you vetoed? What was the rationale?
Effort was being put, I think, into other areas. I think Luce was working on the early polyphonic synthesizer, the one that Keith Emerson hauled around the world, and we sent Richard Wahlberg around the world with him to keep it running. That was an early predecessor of the polyphonic synthesizer. Was in that time period. Um, and I don't know what Norland's involvement was. Norland may not have been in the picture in '74.
Yeah, they were in the picture with the Polymoog because we had the so-called polyphonic proofing paddle to prove that all the notes on it played. I remember that at NAMM.
Okay.
David Friend actually walked up and shook Luce's hand and congratulated him and so forth.
And that was before I worked on a Micromoog, which was later. So that was a polyphonic non-memory machine, was it not? I forgot.
That's right. The Polymoog had no memory except for hardwired. Well, it had a diode or resistor matrix like the old.
But it was factory preset.
Yeah, exactly. You had the front panel, which was your memory, like any instrument that was hardwired. I mean, it was the user's memory.
So I suppose the reason was that we didn't have the resources or something, but I still contend that that would have been an easy project to do. And my sense of the time sequence and when things happen is getting a little fuzzy here. It's 10 or 15 years has gone by, 20 years have gone by. We've spoken of Norland Music. Waitena, in his company Venture Technology, what his modus operandi, I suppose, was that he developed this company called Venture Technology, which was an umbrella company, and his idea was to buy up little companies that were failing because of bad management or not enough money or whatever the reason. But it had something, basically a product that was well engineered or an idea that was good, to put it under his umbrella to get the company up and going and running right, and to sell it off, usually by pumping up the books and cooking the books and making it look a lot better than it really was, because Waitena was, as Robert Moog said, they broke the mold after after God created him. He was Waitena was, in Moog had an unhappy relationship, certainly unhappy for Robert Moog, who basically was, first of all, deceived about Waitena's intention about keeping research and development and modular stuff in Trumansburg. And Moog was forced to relocate against his will, pretty much, to the Buffalo area. Waitena was the type to tell you in basic Anglo-Saxon to read the contract. And Waitena then did things in a way that would maximize his personal profit one way or the other, by hook or by crook. We're using the word crook and not in the sense of something little Bo Peep carried around here. And without regard to what the long-term repercussions were to the industry or to music or to the people who worked for him or anything else, he was out to make a buck. I think one of his phrases was, "Let's talk bucks." Bucks. There were a lot of settling ponds there because they used to because it was a gelatin and works and what do you call it where the
rendering
rendering works, right? Yeah. Dead animals hauled away promptly, well, they were hauled there in times past. And there was a pond. You went out the front door, there's a parking lot, and immediately beyond that was one of these huge old vats full of water, because it was sited on actually the Onondaga Scarp geological formation. So there were springs coming out of limestone all along there. That's why the ponds were there. So that, and after that, the studio was never put back in because the expense of doing the wiring and so forth was such that Moog couldn't get Waitena to rebuild the studio the way it had been at one time, because he considered it a tremendous waste of his money.
All right, we've been talking about failure of the company.
The rise and fall of the Moog works. We've mentioned also, I think the Norland Music was originally well named the Chicago Musical Instruments company. I suppose you'd call them a distributor. They own Pearl drums, Gibson guitars, Armstrong flutes, I think, and did I say Pearl drums already?
They were distributing for Spiso,
Um,
a variety of instruments.
and these are sold to Mr. Music Dealer, or through their sales force who dealt with Mr. Music Dealer. And they thought they would sell electronic music synthesizers on the same route. This is just another commodity. They can buy it at price A, sell it at price B, and after your expenses, what's left over is profit concept. And that was one of the downfalls. And so, anyway, Chicago Musical Instrument came into the picture as a partner. I don't know exactly what the business arrangement is, but I guess they had some partial ownership of the Moog Musonics, as it was called by that time. And eventually, White Tennis sold out completely and was out of the picture. And Moog Musonics then owned the Moog Music Company over a period. This happened over a period of Norland. Yeah, CMI changed its name to Norland, which is the name of the holding company or the main company that owns CMI. I guess Norland's other claim to fame is they had a lock on all the beer and cement in Ecuador. And I forgot where I was leading. Remind me what I was leading
the idea of selling it as a commodity.
Oh, yes. So Norland had this whole structure, the whole marketing structure, and they were going to sell synthesizers on the same route as all the other equipment. There were those in the Moog company, Tom Ray probably being the most vocal, who were adamant that this was the wrong way of doing things, that we should have sold electronic music synthesizers the way ARP were selling them with a team of clinicians who were specialists in synthesizers. That synthesizers were complicated enough, novel enough, different enough from. Anyway, everybody knows what a flute is or a clarinet, and pretty much what you do with it. How a music dealer is supposed to sell an instrument that looks even this complicated is going to be beyond their capability. They're not going to be able to demo it. They're not going to be able to tell the advantages unless the customer walks in, knows what they want, and it's too stupid to know it can negotiate a better price in New York City. He's not going to sell anything. ARP was very successful because they did support the music dealers. And they had people out there who knew how to play synthesizers, who understood electronic music, who could play the instruments and give a demo that would they could go out and live clinics in so that the music dealer could use the local media, the press and the radio, whatever, to get people to come in to see a demo and then get people weed up enough so they could sell a couple of them. And Norland's failure was to assume that you could just force it down their existing conduit and sell these things. Without, we did have people out on the road doing it, but it wasn't the kind of effort that ARP put out. And they beat their pants off. With equipment that wasn't as reliable, it cost more money, it didn't sound as good.
Let's talk a little bit about user documentation, owner's manuals, and service manuals, possibly.
We spoke before earlier about the early days in Trumansburg when no manuals existed, and that customers, if they found out about it and if they had the money, could come to Trumansburg and get 1, 2, or 3 days worth of free instruction in the studio, depending on how expensive a synthesizer they bought. I think there may have been also cases of people who didn't have that, who paid to come in and sometimes and have some of their people brought up to speed. It was very beneficial for us engineers to do that. because we were directly connected to the market. We were out there talking to people who were using them, who were complaining about this and praising that and saying, geez, I wish you could do this. And we, all of us got that. Moog did certainly more than the rest of us. I did, HIMSAT did. We were always working with musicians. And that was a critical factor. But we never had any manuals. There was, in the early days, probably no real need for it, in the sense that people who were using them were audio engineers or avant-garde composers or people who had a lot of expertise anyway, and could probably figure it out themselves or blunder into things. That there were a number of people out there that the manual wouldn't have helped anyway, that they were going to keep moving patch cords around until they found something they liked and never understand it, but record what they'd done so they could do it again. As the company, over the years, as the company moved more and more toward selling through dealers, selling more and more live performance type instruments, unfortunately, our documentation didn't keep up as well as it should have, and that was a detriment. I don't know what else to add to
Actually,
that.
I was thinking more. We had manuals for everything because I wrote most of it
Yeah.
at a certain point.
Oh,
but
yeah,
I was thinking more about specifically the modular equipment.
Oh, the manuals for the modular equipment.
Yeah, I mean, there was non-existent until we quit building it.
Finally got one written,
Yeah,
belatedly, which,
Dan Wyman.
yeah.
Yeah,
And I never saw that manual, or if I did, I don't remember it. So
I got one of them here. I'll show it to you. So, I guess there ought to be a division between user documentation. Well, that's sort of a marketing thing. I'll address that someday. Talking about the demise, and in terms of failure, what does mean time before failure mean?
now we're talking about instruments and how long an instrument will continue to work before you have trouble with it. And the mean time for failure is a statistical concept. It basically says that the mean time before failure is 2 weeks. It means on average, probably once every 2 weeks, it's going to be down for something wrong. If the mean time before failure is 12 years, and perhaps you will throw the instrument away before anything ever goes wrong with it. I think you're alluding perhaps to some of the latter day products of the Moog company, and the Micromoog, I think, was a very complicated instrument, had a lot of parts in it, and didn't wasn't reliable enough. Again, that was one of the periods in the company when I wasn't around, so I actually give you this by hearsay rather than knowing what the figures were or being there having to deal with the problems myself. The instruments that we developed, there was the Moog, which was a fixed program, factory program type polyphonic keyboard instrument. But that brings up the issue of polyphonic versus monophonic, which I don't think we've talked about. The original synthesizers were patch cord instruments played up from a keyboard. The keyboard could only produce one control voltage, therefore it could only, in the general case, generate only a single pitch. So one note at a time instrument, which a clarinet is, which a oboe is, which non-stringed instruments in general are, I suppose, or non-keyboard instruments. Keyboardists were uncomfortable with the synthesizer because they're used to putting down a handful of fingers and getting a chord, and they couldn't do that. And a person who's trained as a keyboard player was frustrated and unhappy with the idea that he could only play one note at a time. People who came from other disciplines, for example, Chris Swanson, whom I happen to know pretty well, was a brass player, was perfectly satisfied with playing one note at a time. That's all he could ever do with a trumpet or a trombone, and played his synthesizer very effectively because he saw it as a soloist for playing a single line. And over the years, the synthesizers developed polyphonic capability and became more and more capable of that sort of playing. A lot of the aspects that were unique to synthesizers were lost. You can't have a whole handful of a lot of these features that you can put into a single voice under your control.
This is take 2 on the 14th of December, early in the morning. Tom Ray and Jim Scott. And we're continuing our discussion, Jim rather, on polyphonic versus monophonic, if you will. Extending this idea that polyphonic and monophonic expression are not the same. And you can only do certain things if you decide to play a chord and so forth.
What happened over a period of time as instruments became polyphonic is they became more of a keyboard instrument, more of an organ and less of a synthesizer. They gotten far away from the concept of moving patch chords around and producing sounds that could be produced no other way. And I think most often musicians were playing sounds that were reminiscent, if not duplications of things that could be done on acoustical instruments. So that's certainly a trend that has occurred over the years, and
And of course, as polyphonic instruments,
the expressiveness, you lost the expressiveness, some of the unique expressiveness that you could produce with a one note at a time instrument, bending notes and so forth. There's a lot different bending a single note than is bending a chord, because it starts sounding like a steel guitar.
but this idea about failure, it's not just an engineering effort necessarily. The instruments became more complicated. So why don't you? I mean, as they became polyphonic.
Yeah, and polyphonic, and this, of course, we were not designing digital instruments in those days. These instruments were purely analog. So a polyphonic synthesizer that could play 20 notes at one time or something like that required the equivalent of 20 synthesizers inside. And it had to be, as I've alluded to before, 20 simple synthesizers, not 20 complicated synthesizers. And so the tone generating and timbre producing characters of being able to produce tone colors over a wide range was lost in favor of doing fairly accurate reproductions of organs, pianos, violins, and so forth. And aside on string instruments, I always thought that string synthesizers are always a failure because of the equally tempered scale. You couldn't play chords perfectly in tune as string players can. And I always thought they were pretty awful sounding, no matter whose string synthesizer you listen to.
It's true today with samplers; they're still equal to.
And well,
the sound is better, but the tuning is still just as great.
Now that that all the tuning is done digitally, I've always wondered why it wasn't possible to have the brains within the instrument to when you're playing string sounds, to have the instrument decide not to play an equal temperament, but actually play real fifths and thirds and sevenths and whatever. Sevenths, it probably doesn't make any difference. It's atonal anyway, but it's tritones.
Thirds, yeah.
Oh,
are critical.
Yeah, major and minor thirds. Fourths, everything. Play them in tune in strings, they're going to sound an awful lot better than if they're an equal temperament, which is always going to be, I don't know what it is, a few cents out, 10 cents out, whatever it is. One direction that never developed, and we're getting away from the subject of why Northern ultimately, or why Moog music eventually failed, but we're on the subject of monophonic and polyphonic. One area of synthesizers that originally Robert Moog would put the idea in my head was things he said was the whole area of controllers. So why a keyboard? Well, keyboards, you can buy them from Pratt and Reed Corporation. They're already assembled. You stuck them in the case. Musicians could play them and understand them. Keyboard or non-keyboard, anybody can do something on the keyboard. A keyboardist or non-keyboardist, anybody can. Even a non-player like myself can fool the uninitiated for a moment or two that I might be able to play. But there are all kinds of, if you look in the orchestra, there are people blowing in the ends of tubes and fingering notes, and people bowing and percussionists and so on and so forth. So I think it's been a failure or a lack in the synthesizer industry that more uh, d- uh, products weren't developed that where people could use their particular skills, that a violinist could pick up something that they could finger and bow and play a synthesizer. The synthesizer is the sound generating equipment that has all its capability, and the little fake violin you're playing, little electric violin, mechanical device you're playing, allows a violinist to use the skills they have to see what they can produce from the synthesizer and to get expressiveness and so forth. And the same with wind players who articulating with their tongue and using lip pressure and fingering and slurring or not slurring notes and so forth. Why not give the woodwind player or the trumpet player uh, a controller that they can hold in their hands and use the skills they've been honing for the last 5, 10, 20 years, however long it's been, to get control over, to be able to get control over the capabilities of the instrument. In all these cases, too, you were talking about a monophonic instrument. Could you? What does a polyphonic clarinet mean? Not much.
Yeah, even if you could play 5 notes, you can't control 5 of them independently. You can't control them as though there were 5 people, certainly.
Yeah, two.
That idea of an orchestra on a keyboard, you might address your thoughts on that, you know.
Well, I don't know if I have any direct thoughts on that. I know a lot of work was we used to have a lot of confusing discussions. You and I and Moog have gone around and around on the middle ground between a single note instrument and a fully polyphonic instrument where all 88 keys can play at the same time. There's also the issue that we've beat around for years about making a note that plays 2 notes or 4 notes and having the equivalent of 2 or 4 synthesizers under your control. 2-note instrument, if you played a chord, presumably would play the high note and the low note, or the last note played. And we had a lot of discussions on priorities, and it got really complicated if you assume that the 2 timbres are different, that one of them is, just for sake of example, one of them is, the trumpet and the other one's a flute or something like that, and you're trying to play both of those. And whether to split the keyboard physically, so this half of the keyboard is, this half of the keyboard is the trumpet, and this half is the flute. Probably not very good orchestration trying to make a trumpet go with a flute, but or whether you wire the musician so the left hand or right hand or sense as to which hand is which for which instrument. And we've gone around and around and around and around. I think that to no general consensus ever as to how there were synthesizers built that were where you have also the question of priority. In the classic Moog instruments, such as this one and the Micromoog here, and the MInimoog, it was low note priority. I played several notes, always the low ones sounded. And also there were the characteristics of this keyboard such that if you had an open keyboard and you pressed a key, you got a trigger, and that trigger then triggered the initiation of a note. You got the attack transient of a note. The note would then typically sustain at some level until you released it, then it would stop. But if you held a note down, you get the attack transient. But now if you pressed another key someplace, the pitch would change if you played a lower note. If I play here and then play a lower note, the pitch changes to the lower note, but there's no new initiation of the sound. There's no new envelope, no new attack on the note.
That was single triggering.
Single triggering. That's the way the MInimoog, that's the way Moog synthesizers in the studio were built. And that was simply a constraint of the equipment. Not much more you could do. The MInimoog carried that on, then the Micromoog carried that on also. And I think there were probably the Minute Moog and some of those other instruments also carried that into. You could argue about whether it should have been high note priority. It's probably, or do you want to have a last note priority? So whatever the last note is, I press, no matter where it is, that's the one that sounds. And those were probably, well, they were doable, but those were probably pretty complicated to do with it. Was just when we were building circuits with just discrete transistors. But as integrated circuits became available, and the fact that microprocessors came down to a few dollars a piece, you can build keyboards with the brains built in the keyboard, and you can tell the keyboard what it is you want out of it for triggering and for priority.
The irony of it is as soon as you can do that, people forgot that it was important to do to have brains in the keyboard as soon as you could do it. Although there's some interesting things.
And then all those issues of triggering and note priority, all that stuff got much more complicated. We started talking about even doing a 2-note instrument to play. Because ideally, you want to play a 4-note. You'd like to have 4-note capability in an instrument like this, so you can fully define the harmonies. Um, uh, so that's far from our subject of what happened to the Moog works. The Moog works, by the way.
Before failure.
The Moog works, by the way, was not an official term. That was one of the engineers, Bill Hemsath's nickname for the company when we were in Trumansburg. He tended to invent names for lots of things, including our customers, but I won't repeat those. Some of our customers. We were on the subject of why the company failed, and I'd like to try to close on that a little bit if I can. Northern Music came into the picture. They then began to impose more of a structure on the what had been a bunch of a very much engineering dominated company, where the engineers were basically the marketing as well, because we were in direct contact with customers all the time, both training them and listening to the complaints and listening to the suggestions. And we were forced to listen to a lot of people, a lot of the very divergent opinions, and sometimes people asked for things that didn't make any sense. They were asking for things that logically, if you carried on what they said, was an absurdity. You just for what they had asked for, you just point out to them, well, if you get this and you get that, look what's going to happen over here. Oh, I never thought of that. Did that? There's a lot of that. As Northern Music began to impose their marketing on the company, what happened was that those people often conceived of possible new products in terms of things already known, of combinations of what had been done previously in synthesizers or other instruments, and they weren't thinking in terms of as innovators, of whole new ideas that could be brought in and used. That was one of the failures. Also, the people doing the marketing often were, some of them I think were purely marketing people. They didn't know music. Some did, some didn't. And that was certainly a detriment. So we got into a situation where some of the engineers, myself and Luce and Moog, we had some pretty damn good, still have a lot of good ideas, but we're being pushed on a path to develop instruments that from New Orleans' point of view look like the proper path to pursue. And there was that disagreement, and I think it didn't do us any good. I think we ended up doing things, designing instruments that were impractical, the market didn't need, or had the wrong features. The big failure was the failure to go after a polyphonic instrument right away. And by the time when I first saw the Prophet 5 from Sequential Circuits, it was a 5-voice polyphonic instrument, or 5-note polyphonic instrument. We were Peter Gabriel was in town, and we were backstage looking at their equipment. And the band members were 807 musicians from the city who were commuting back and forth. They'd play a gig one night with Peter Gabriel, the next day they'd fly back to the city and do studio sessions. The next night they'd fly back to the next gig. And one of them had a Prophet 5, the first time I'd seen one. And I looked at it and said, "We're done for." Basically, this is, or not, maybe not those words, but this is where we got to be. This is the instrument. This is going to sell. This is what the market wants. With a programmable and 5-voice, it was polyphonic, and sure enough, you can get from sound to sound to sound instantly. One aside on the Prophet, I talked to Dave Smith. His name is right. The guy that the president of the company, founder of the company. Some years later in California, and he said that something like 70% of the instruments, when they came back for repair, the presets, although they're completely programmable by the user, 70% of the cases the customer never touched the factory sets, left them all alone. So the people weren't using it as a synthesizer at all. They weren't doing anything with the control panels other than just punching and playing. I think one way to combat that is it probably was a marketing mistake to program all the presets. They should have programmed half of them and left the other half blank, so they weren't afraid to lose the factory presets. Um, um, but that was the beginning of the end, I think. After that, Moog spent a lot of time and money developing the memory Moog.
But you built a polyphonic instrument prior to that.
I didn't. It was a polyphonic, but it was a memory. I built the first prototype of a memory Moog. I had been away from the company for the third time, and I returned to the company for the third time to work for the company. And this time, I was not working in Buffalo. I was working in a studio apartment in Ithaca, New York, and I was charged with the responsibility of developing a memory synthesizer. I was uneasy about the project because I thought it should have been microprocessor based. It should have had a little chip a computer chip on board. I went ahead and designed the whole thing using discrete logic, just integrated circuit chips, and it ended up taking a lot of parts. But I went ahead with it, and with the idea that at least I could get a functioning prototype that had the function, that did what it is we wanted to do. But I kept suggesting that perhaps somebody at the Moog company get up to speed on being able to develop a microprocessor to do most of the control function. I had all this big board this big full of digital circuitry that worked, but it seemed to me that it wasn't a practical thing to try to produce, because somebody obviously is going to come along and do this, get a similar level of function and complexity with one chip and a few. I worked on that for about a year and delivered it. It had a lot of features on it, that prototype, that were probably a bit ahead of the time. Then I don't think too much of that design ever made it into a production instrument. It was David Luce was working on the next version of the memory Moog, and that design, I don't know that it incorporated any ideas. It probably did, but I can't tell you any ideas that were incorporated off the initial prototype. What I designed for the first go around the memory Moog, I don't think would have been successful because of as it stood, because of the lack of microprocessor. If it had been taken so that it functioned exactly as I had it functioning, but re-engineered for inexpensive design, I don't know. Would have been successful or not. We would have got the market faster.
Yeah, it took 3 or 4 years before there was finally a memory. At least 3.
And we were more like 6 months or a year away.
Yeah.
With the first prototype of the memory Moog. Yeah. The memory Moog, I don't think, was a financial success. I think you spent more money on repair than you did on making profit on the thing. And of course, you lost a lot of face and credibility in the market if you have a machine out there that breaks all the time. And I wasn't around when that was happening, so I wasn't paid.
I don't remember the exact number, but it seems to me that there were something like 150 trimmers in it, and in the Rhodes Chroma there were 3.
Yeah, when you have a microprocessor-based system, a computer-based system, the amount of trim cost goes to almost nothing, because everything's auto-tuned and digitally trimmed and accurate in the first place. So if you have digitally generated envelopes and so forth. What about the sound quality of the Micromoog?
I thought it was outstanding.
So was it?
Oh, it was a big success. I mean, the sound quality was without peer. And still, it's a lot of people love the instrument, but it didn't have MIDI. And then we implemented MIDI in a late and kind of halfway fashion. You would only do notes and programs, basically. And it was too little too late. It was too expensive.
Too expensive, yeah.
Yeah, the biggest problem was it was too expensive. The market by that time was demanding an instrument around $2,000. And that to me, in my segment of doing this, I'm going to state it unequivocally that the latter day engineering group certainly was never sensitive to price. It was just, well, we're always just building Cadillacs, aren't we? Without realizing that it's fine if you have a corner on the Cadillac market, but we didn't. We needed instruments of all stripes, and we just couldn't proliferate because there was very little interest.
You just mentioned also that eventually Robert Moog himself got out of the company. He first moved his own laboratories from the plant to his home in East Aurora, where he was to do advanced development type of work to support a skunk works, a one-man skunk works, independent of the main organization. And then later on, eventually sold out completely and started his own company, Big Briar Incorporated in South Carolina.
North Carolina.
North Carolina, sorry.
Sorry. It doesn't really matter down there.
Asheville.